battery-based sizing video series. In this video, we're going to be identifying the number of batteries in series that are necessary for the chosen inverter, and a little bit of information about inverter sizing also. Inverters always have a DC input that is either 12 volt, 24 volt, 36 volt, or 48 volt. Smaller systems, such as for charging a cell phone or something like that, are probably just going to have a 12 volt input. Even for running lights and everything like that. You can find inverters that are up to 2,000 watts of output that are 12 volt inverters very commonly. But as soon as you get to a larger inverter, let's say a 4,000 watt inverter, maybe even a 5,000 watt inverter, they almost all go up in size to 24, 36, or 48. Nearly all residential whole house battery-based systems operate off of 48 volt. The advantage with 48 volt is it is more efficient, and it can be used with smaller wire sizes and smaller DC disconnects. That's very important. For example, if you had a 100 amp DC 12 volt system, you could actually accomplish the same amount of power with a 25 amp 48 volt system. So much smaller wire sizes, much smaller AC disconnects. Therefore, most of your whole house off-grid PV inverters are going to be a 48 volt system. So how the math would look is, once you know what the voltage of your inverter is, we're on question number 3 now. Enter your voltage of your inverter and divide that by the voltage output of your batteries. So for our example, we have a 6 volt battery, and this 6 volt battery, we're going to need 8 of them. So 48 volts divided by 6 volts each equals 8. That means 8 batteries will be connected in series, so that at the end of your connections, you have one positive and one negative terminal that are left unused. And if you were to check with your voltmeter from those terminals, you would see a voltage between the two of greater than 48 volts. Depending on how fully charged the batteries are, a fully charged battery bank would probably show 50.4 volts. That's our first step for determining how many will be connected in series. So the next question that asks you is how many watt hours that you can get out of each series string over 3 days. So the first thing that we need to do is look back at some of the math we've already done, and we've already done this math to determine what one battery would provide us over 3 days. This is 6 volts times 245 amp hours. We saw that in one of our earlier videos. It gave us the watt hours of the battery, but we're only allowed to use 70% of that before we will consider to be over discharging the battery. So we only have 1,029 usable watt hours for one battery. So if I take that 1,029 usable watt hours and I multiply it times 8 batteries in series, it tells me I have 8,232 usable watt hours of power over 3 days without over discharging these batteries. The problem is that's still in DC power, and my loads are almost all going to operate in AC power. So I also must derate this usable power by the inverter efficiency. Now, I have provided you the inverter efficiency, 93% efficient. However, in the real world, you're going to need to find your inverter spec sheets and find the inverter efficiency for that particular inverter. Most inverter spec sheets give you multiple inverter efficiencies. Some of them are high, some of them are a little bit lower. My recommendation for sizing is to use the lowest inverter efficiency that is provided to you. So I've used an inverter efficiency of 93%. So I simply take my usable watt hours for one series string, I multiply it times 0.93, and it tells me that I would have from one series string 7,655.76 usable AC watt hours. Hopefully from this, you guys grasp the concepts that there are different in DC inputs for different sizes of inverters, that DC input in the inverter will determine how many batteries in series must be connected depending on the voltage output of your batteries. And once you know how many are connected in series, you can then determine how many usable watt hours I would be able to get from one series string.